Functions Unit 3 Video Assignment. Functions and relations. Here we have a relation. Over here, all these numbers will be considered an x value, which can also be known as a domain. And all of these numbers are y values, which can also be known as range. I know this relation is a function because each value from the x values can only correspond to one of the values in the range, which is the y value. Over here, I know this is not a function because if an x value has two different y values, it is not a function. It is simply just a relation. Next, we'll be working on the vertical line test. In these examples, I used a dotted line to represent the use of the vertical line test. I know in this relation, it is a function because after using the vertical line test, each point on the graph only intersected once with the relation. However, on the other graph, right here, the vertical line test failed because it intersected more than one point on the relation. Now we will be doing function notation. In this example, I'm going to be using equation f of x, 2x to the power 2, 10x subtracted by 9. I'm going to be evaluating for f of 3. So f of 3, of course, the 3 would substitute for the x's. And over here, you would input the 3's. Once you input the 3's, you do 3 to the power of 2, which would give you 9. And because of the brackets, that just means you would be multiplying the numbers. So you would multiply 10 by 3, which would give you 30. And the subtracted by 9 would just stay as is. Next, you do 2 times 9, which would give you 18. And then the 30 would remain, and the subtracted by 9 would remain, which would give you the total of 11. And therefore, the output of this function when x equals 3 is 11. Continuing on function notation, here's another example. I'm going to be using the equation of g of x equals 2x to the power of 2 plus 8x plus 2. Next, we'll be evaluating for x when g of x equals negative 2. We'll start with moving this negative 2 over here, giving us positive 2. Using the quadratic equation, we'll be subtracting a for 2, b for 8, and c for 4. This will find the possible values for x. Therefore, the inputs for this function would be plus minus 2 plus the square root of 2. Now we will focus on domain and range. Domain describes a set of values on the x-axis, and the range describes a set of values on the y-axis. The domain and range is a general notation. It consists of a set of curly brackets. This right here represents what a variable belongs to. This right here represents the set of all real numbers. This line in the middle represents such that. And finally, these two greater than symbols, they represent greater than. In this specific example, you would pronounce as x belongs to all real numbers such that x is greater than value a and value b is greater than x. The domain and range of this graph would be x belongs to all real numbers, and y belongs to all real numbers such that negative 4 is less than y. Now we'll be focusing on parent functions and transformations. So the parent functions are the linear function, the quadratic function, the square root function, the reciprocal function, and lastly the absolute value function. And the one we'll be focusing on is the square root function because that's the one that I am using in my equation. Moving on to transformations, we'll start with the transformation formula. The formula uses vertical and horizontal transformations. The variables a and c result in vertical transformations, while variables k and d result in horizontal transformations. Vertical translations occur because of the c value. If the c is greater than 0, then the function shifts up. If the c is less than 0, then the function shifts down. A vertical stretch or a compressed or compression occurs because of the a value. If a is greater than 1, then the function stretches by a factor of a. If it is less than 1, then the function shifts down. For my example, I will be using the equation y of x equals negative square root 1 over 2 x plus 4 plus 3. The values are a equals negative 1, k equals 1 over 2, d equals 4, and c equals 3. Now I'll be focusing on the base functions, starting with the x values being 0, 1, 4, 9, and the y values being 0, 1, 2, 3. I then applied the transformations from my equations, which were horizontal sketch by a factor of 1 over 2, reflection across the x-axis, and then shift 4 units to the left, shift 3 units upwards. This resulted in my transform functions here, which are the x values are negative 4, negative 2, positive 4, positive 14, and my y values being 3, 2, 1, 1. Now moving to inverse of a function. The inverse of a function is denoted as f to the power of negative 1 of x. The inverse of a function has all the same points as the original function, except x and y values have been reversed. When finding the inverse of a function, I replaced fx with y. Then I factored the equation and I switched the x and the y variables. Afterwards, I continued to isolate for the y. Finally, I replaced the y with an f to the power of negative 1 of x. In example 2, I graphed my inverse function. First, I graphed and gathered the main points of my original function, which was f of x equals negative x minus 1 squared in positive 5. And then I put them in this table over here. Then I reverse the values of x and y in order to get the main points of my inverse function. Then I wrote them down in a table. Finally, I graphed the points of my inverse function, as you can see here.